Oh hey, didn't see you there. Hello future Taejung. Today we're going to do the Quideo on chapters 3 and 4, which deals mainly with scatterplots. Let's jump right in. Here are Professor Moore's times in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool. A. Verify that a linear model appropriately models the data and state the equation of the linear model. So first, you would plug in all of the 23 sessions, which you have done. Next, well, after you've turned on your diagnostics, you would go to Stat Calc 8, which is your linreg, which, well, I've done above. And then you see that the residual is actually 0.56 approximately, which is not very strong. So you would have to find the residual plot to make sure that it's appropriate. So you go to Edit, go all the way to the right, and type in resid in the empty blank space, which you have done. And then you go to stat plot, change the y-list to the residual, and then press zoom 9, and there it is. Oh, that's a beautiful residual plot. It is unbiased and homoscedastic. So the answer is a linear model appropriately models the data because the residual plot is unbiased and homoscedastic, the perfect residual plot. And here's the equation that you have found using linreg. Part B. The next day's time is 34.3 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. How accurate was your prediction? So since you're looking for the pulse rate, all you have to do is plug in the time into the equation that you found in part A. And after you've done that, you find that the pulse rate is predicted to be 147.3990 beats per minute. And it says how accurate? Well, his actual pulse rate was 152. So if you subtract 152 and 147.3990, you were approximately off by 4.601. Suppose you were told only that the pulse rate was 152. You now want to predict the swimming time. Find the equation of the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? To find the answer, you have to flip the L1 and L2. Just switch the places. So you go back to linreg, L2, L1, farce, function, and there is your new equation. So the new equation is time with the hat on top because it's predicted, of course, 43.097 minus 0.057 times the pulse. So like I said, you just flipped the L1 and L2 because, well, you're looking for the time and you're given the pulse. And so plugging in that 152, there it is, you find that the predicted time is 34.43. While since the actual time was 34.3, you are very, very accurate. You're only off by 0.13. And lastly, part D. Explain clearly to someone who knows no statistics why there are two different regression lines. So as you can see, there are two different lines, one for pulse and one for time. So the answer is, there are two different regression lines because there are two different predictions to be made for both pulse and time, leading to two different equations.